When you hear the word work, what's the first thing you think of? Maybe mowing the lawn or working out. Maybe taking operator rounds at SRS. In physics, work is defined as a force acting through a distance to change the state of motion of an object. Mathematically, this is expressed as work equals force times distance. For example, if we have an object and it takes 50 newtons of force to move that object 5 meters, we say we have done 50 times 5, or 250 newton meters of work on that object. A newton meter, the unit of work in the SI system, is also called a joule. In the English system, the units of work are expressed in foot-pounds force. Let's look at another example.
Force times distance is only one of the ways that physicists measure work. Because you know how we just said that joules are the units of work? Well, joules are often used as the units for something else. Energy. And work uses the same units as energy because work is just a change in energy. It's what happens when an external force is applied to a system and changes the energy of that system. In fact, that's one of the ways to define energy. It's the ability to do work. There are all different kinds of energy, but in this episode, we'll mainly be talking about two of them: kinetic energy and potential energy. Potential energy isn't potentially energy, it's potentially work. In other words, potential energy is energy that could be used to do work. One common type of potential energy is gravitational potential energy. Basically, the potential energy that comes from the fact that gravity exists. If I hold this book about a meter above the ground, we'd say that it's got gravitational potential energy, because if I let it go, gravity is going to do work on the book. Gravity exerted a force that moved it to the ground. Once the book hits the ground though, we'd say that its gravitational potential energy is zero because gravity can't do work on it anymore. Calculating gravitational potential energy is easy enough. It's just the force of gravity on the object, so the object's mass, times small g, multiplied by the object's height, or mgh for short. Which means that just by knowing that this book's mass is about a kilogram and that we held it about a meter above the ground, we can calculate its potential energy, which is 9.8 joules. Kinetic energy is the energy of motion. When the box was resting on the ground, we'd say that it had no kinetic energy. But once you applied a force and it started moving, it did have kinetic energy. And the energy of the box changed, which means that you did work on it. More specifically, the kinetic energy of an object is equal to half of its mass times its velocity squared.